Hello, it's James from xrobots.co.uk. I'm really close to the camera because my audio equipment is broken. I don't have a microphone, so sorry about that. This is the next part of Project Ultron, which I've got just here. So I've been building up this life-size Ultron with 3D printing. I've been doing quite a lot of testing on robotics mechanisms. Look at the early episodes. So this time I'm going to be getting on with the design in CAD, which I've been showing as well. Last time I built some of the shoulder hinges here. We're going to continue to make those parts, and also look at series elastic actuators, which I mentioned in episode 4 and at the end of last episode. So I'm going to be building shoulder hubs which have basically force feedback sensors in them and doing some testing on that. And that's going to form the basis for the shoulder mechanisms. The first thing I'm going to do is print some more of the shoulder pieces. So I'm going to print these giant sections in here, which are basically most of the lever mechanism. So these are going to need to be cut up to be printed. Obviously it's quite a complicated piece. I'm going to print that and this lever, and then after that we can work on the shoulder hubs. So I've cut the parts up here so they fit on the print bed, and these can all be printed in individual pieces. They're all going to be printed in ABS so they can be solvent welded back together when I'm done. And I've left these sort of keys so they plug in, and I've divided these into two with a little lump that will screw in there to try and fit that back together. So hopefully they'll all go back together and make one large piece, which is the main shoulder pivot hinge. Right, here we are. So I've printed all the pieces. They've come out pretty well. They're all large ABS pieces. There's hardly any warping. So pretty happy with those. Tiny bit in that corner. But on the whole, that's just a bit of the brim that needs trimming off. So yeah, on the whole, really good prints. Some of them were printed lower density. So this piece, for instance, is much lighter and it's only 10% infill. You can see the top surface has suffered slightly there. And that's because there's hardly anything to print the top surface on. There's still 4 top layers, but it's got a bit churned up. But basically these should have some sort of pattern on, so I'll be printing a flatter plate with a veneer basically to stick on with some patterns on that cover that up, so I'm not too worried about that. But all these parts should lock together. So that goes on there, that goes on there. I've got this little bit, as I said, which goes across the top. So I need to just knock out the corners with a file there, but they should fit together pretty well and they can be solvent welded. And of course this piece is made of 2 bits, so that's the main pivot, and that's where the hub hinges, and that's where the whole thing gets pushed up. So that is, I can even get it apart, a really tight fit. So again, I just need to attend to those edges with a file and they should fit together really well, and we'll make solvent welds and build these whole pieces up. As usual, I'm using some acetone to make a solvent weld there, and I've also got some ABS dissolved in acetone, which I probably don't need because they're a really tight fit. I'm just going to put some acetone on all those surfaces that touch. It evaporates pretty quick, so we have to be quick about it. Just use some of that stuff as a filler. Just put that on some of the surfaces where maybe there's a gap. And making sure everything's the right way round because it will never come undone. Push that together. I can just go over the edges with a bit of acetone and the capillary action will draw it into the gaps as well. And that should make a pretty strong solvent weld, so I'll just put the rest together as well. Right, here's one of them, all solvent welded together, and it's pretty tough actually. The top doesn't really have any load on it, which is why I did these in a lower density infill, apart from this which has the clavicle, which is just for show really, so I think that's going to be fine. The main lifting part is in a pretty high density infill, as I said. So I've got some bearings fitted there, which are 8mm internal diameter on each side, so a piece of 8mm studding goes through. Pivots on this piece I made before, and obviously I fitted one here, so let's just rest that in there. So this goes up and down, and obviously they can move forward or they can swivel like this. So I think that's pretty good really. So the next thing I need to do is build the actual shoulder hub that holds the shoulder, and of course this lifts, and because of the leverage the shoulder hub lifts even more to move that whole arm out. So have a look at last time for a bit more explanation on that, but this is more than enough leverage here. So they can come up, not till they quite touch because we need to get the neck in, but that's more than enough motion there. So I think that's pretty good, and obviously an actuator pushes from underneath, which will be right in the bottom. So let's talk more about this shoulder hub. So this is the piece I've just made there and attached, and we've already got the internal parts of course from last time. So now we're going to make this hub that the actual arm mounts onto, and last time I discussed that that would have a force sensor in it, so between the red and the blue parts there would be a sensor that will be able to detect how much pressure is being applied, either back driven or if it crashes into something. And we looked at some electronic components called force sensitive resistors in order to make that work. So there's not going to be much rotation between the red and blue parts, but we do need to get quite a big scale of some sort of variable out of there so that we can detect the motion really easily. Last time we looked at a couple of options, and I think what I'm going to use is the force sensitive resistors. So these are basically pads which when you press them they change resistance quite dramatically, but there's nothing really squashy in there at all. They're pretty much solid actually. They've also got a self-adhesive backing which makes mounting really easily, so I can use those inside that shoulder hub, so basically when it rotates in either direction it causes these to get squashed. What I really want to do is set up a pair of them in each joint, so that when the joint is being pushed one way it squashes one, and when it's being rotated the other way it squashes the other one, and when neither are squashed basically that gives us a reading right in the middle. The problem with this is that when they're not being squashed they read infinity basically, so they're almost completely open circuit, and that makes it quite tricky to make a potential divider. So I'm going to do a bit of electrical testing and see what we can do about that. So what we're going to do is build a potential divider. So we're going to have two power rails here. We're going to have 5 volts at the top and 0 volts at the bottom, and then we've got our two force sensitive resistors. We're going to put them together like this, and then this point in the middle, if these values are the same, let's call them X, then this will be exactly half of 5 volts, so it'll be 2.5. And as these values vary, as one gets more and one gets less, as we push and pull, this value will go up and down based on the ratio. The problem we've got is at some point these are completely open circuit, so they are infinity, which is a bit of a problem. It probably means we're not going to get anything here at all because there's no current flowing. But let's put that together and see what happens. So here we are. So I'm just using an Arduino Uno powered from a USB boost adapter, and that's just giving me 5 volts, and that's all that's attached. But in reality I would use an analog in to read that value in the middle, and then we could see what forces are being applied. And I've set up my force sensitive resistors here, so I've got exactly that arrangement where I've got 5 volts coming in the top, ground is going out of the bottom, or 0 volts, and I've got my multimeter attached which is reading this point which is in the middle. That's also attached to 0 volts, so it works. So you can see at the moment I've actually got 0 as predicted, but if I tip this over and I press the top one, then that starts allowing current to flow, and it very quickly goes to 5, probably because there's nothing in the bottom to put it down to ground. And if I now press the bottom one, and that starts to pull it down to 0 volts. But if I let go of the top one, it immediately goes to 0, and if I let go of both, it goes to 0, and that's because there's no current flowing through here, so all we've got is 0. So what are we going to do about that? Going back to our diagram, what I'm going to do, in fact, as you may have guessed, is add 2 more resistors here of a fairly high value, all linked across as well. So these are in parallel with these, and these are going to be around 10 kilo ohms, which is 10,000 ohms, and that will make sure that this always centres in the middle, and when these get pressed it'll basically have a massive influence because these go down almost, well, to a few hundred ohms, which overwhelms this and most of the current goes this way, so that still means my potential divider works. So let's get two 10k resistors and stick them in parallel with the force sensitive resistors and see what effect that has. So hopefully you can see those two blue resistors that I fitted there, and those are in parallel with the force sensitive resistors, and those are 10 kilo ohms each. And when I say ground I mean 0 volts, by the way, it's because I'm old. So now you can see that my meter is reading about 2.5 volts, which is right in the middle, and if I press one of these it goes up. I can't quite get to 5, but that's fine, and if I press the other one really hard it goes all the way down. So that means that I can put these inside the hub and have it apply force to one when you push it one way and the other one when you push it the other way, and there's hardly any motion, so I can detect when that joint is being back driven. Here's my design for that shoulder hub. So the blue and purple parts will be solvent welded together. Those are split up for printing, so they can both be printed flat on the bed. And the red parts are going to rotate independently from them very slightly, and I need to insert the force sensitive resistors between the two parts so I can measure how much. So I've put some details on the front of this, but what's inside is what's important. So what I've got there is a central kind of hole there where I can fit bearings in the blue parts back and front. So a piece of studding can run through to allow the red parts to rotate against it. And then the green parts are kind of a core, which obviously stops it rotating, and I've got space for these inserts. So in two of those will be something rather solid, either solid NinjaFlex prints or ABS or a combination or some other material, which will act as a stopper to stop them moving against each other. And the other two inserts I'll be inserting the force sensitive resistors packed out with some other material, and that allows me to adjust sensitivity and adjust the amount of pressure that's applied to the force sensitive resistors by adjusting the stoppers essentially. So I can adjust these as I go, as I build the robot up, and we can see how well that works as more mass is added to the arm. So obviously I need to get wires out of there. So in the back surface I've got these channels which allow the wires to escape, and this is the back of Ultron essentially. This is the front, and you'll notice looking at the front, the attachment on the red part, which are these parts with 3 holes in to attach the arm on, is facing out at a slight angle, and the arm naturally hangs out at around some sort of 15 to 16 degrees, which means that obviously it'll have greater scope to move outwards as the whole mechanism goes up and down. And we've got the bearing holes in the part sticking out of the middle piece, which will be driven by the actuator and the rest of the arm assembly. So let's get those all printed. I need to print quite a lot of pieces. Obviously I need to make opposites as well to make both arms, and these pieces are quite large, so that's going to take quite a lot of time. So here are those parts. It's a couple of days later. It took quite a long time to print all of them, but we've got the tops and the bottoms, we've got all of those cable channels in there, and essentially what we've got, these are printed in 2 halves. Whoops, they're a really good fit. I put keys in, so these will fit together really well, and all I did was just knock those back by 0.2 mil, so they fit together really snugly. They're going to be solvent welded together, but there's virtually no movement between them. And of course what happens is this goes in here. We can mount bearings in here and a piece of studding all the way through, and you can see that this will rotate a little bit, but not at all that much. And then I can put wedges in here of different materials to dampen that motion. In fact, it'll hardly move at all. The plan is to put something much firmer in the ones which don't have the force sensitive resistors in, to dampen that motion a lot, so that the fault sensitive resistors don't get squashed too much. But I'm going to assemble that, and then we can experiment with some hybrid prints of maybe ABS and NinjaFlex and various materials to shove in there and see what happens. So here are my opposite shoulder hubs assembled. So obviously inside here now we've got a piece of studding that runs all the way through that allows this to rotate against this, which is where the arm is fixed, and this is the anchor point for my lever mechanism for that whole shoulder. So we've got a washer on the top there, the studding runs all the way through, there is a washer on the bottom, and this piece has bearings, top and bottom, on all of those joints, and it fits quite neatly on there. And then of course the core is fixed to the back and front, so with the 4 screw holes in there. This is then screwed down when the sensors and blocks are in, so that should make the outside very rigid. Obviously the arm is bolted on, which also holds it, and the inside is rigid so they don't twist. And obviously this is the opposite assembly, which is good that I remember to make opposite parts. Alright, so now what we need to do is put some inserts in, and I'm going to try with some solid NinjaFlex in these two, which will stop that moving. And then probably we'll want something slightly softer in the other two with the fault sensitive resistors sandwiched in there. And that means that I can make this very firm, but basically I can squash the fault sensitive resistors as much as I want as load is applied to this arm to sense how much there is and to sense when it's being back driven. And I'll probably need to adjust that as I go and build the arm out, because of course as the arm gets heavier that's going to exert more force, at least on one of them. And I could adjust the material so they're different in each case to try and balance that up, or I could do it electronically, but we'll have to see how that goes. So I'm going to print some blocks to put in here. Obviously the fault sensitive resistors wires come out of there, which is why they're on this side. Right, I've printed some NinjaFlex blocks and some other shims which I've printed in ABS. So if we take the top of this one, we should find that we can insert these like this and these like this. And I thought these were a fairly snug fit and it's pretty hard to get them in, but in fact it still allows some motion. And the other side has got them inserted, and you can see there is quite a bit of motion there, or at least a little bit. But I'm not sure if this is right or wrong really, because I do want some movement. The plan is probably going to be, once the force sensitive resistors are inserted, to put something much softer in that side. So it may even be some layers of craft foam or something fairly dense, or it may be a bit of NinjaFlex in a lower density infill, and then some foam to press these so they don't get pressed really hard straight away. The idea, as I mentioned, was to have firmer stuff in here so that I can control the amount these are pressed, and obviously it's got the load of the whole arm on. So for now I'm not going to try and tune this up because I really don't know how heavy the arm is going to be, but that's the basic principle, that we've got these pressure pads pushing these and we can get force feedback. And this is only for the feedback on the joint, it's only for to measure the load, it's not actually for sensing the angle that it's at. That will come into the actuator that I'm going to build next time. So I'm going to get this top screwed on and then we'll mount these onto the torso. Here's the current state of the torso. So these pieces were on before, but I've now attached these levers, so my new parts will go between these 2 points. And the levers they don't move very much, so right at the bottom there they go into those points, and they don't have bearings, they just have some 8mm smooth bar which goes in here, and that's what allows these to pivot. So I'm now going to mount those shoulder hubs on each side, and we'll see how much motion we get when the shoulder lifts. So those are fitted, and the sort of range of motion I get is pretty much this, so they can move all around, and these angles here are where the arms are attached, so if you can imagine that coming right out to here, then that's pretty much okay with me. Obviously the torso can move up and down, so it can always move like this as well if it needs to, but I'm pretty happy with that range of motion. And as you can see, this leverage mechanism is working with this long rod to pull this back, even though this part isn't moving very far, which is kind of what I'd intended. I'd like to have had longer levers in this part that went down lower, but of course they can't do that because they'll be crashing into the actuators below. Now at the moment this looks quite wobbly, and that's because basically there's no actuators with any end stop on these, so they're kind of pivoting on the range of motion that they've got. But if I put in some temporary blocks, you can see that they're much more solid. So once those actuators are in place and they actually have a hard end stop on, then most of that wobble has gone away. So that's much better. There is some wobble side to side and around with the flexible spine and the other actuators I built, but of course there's going to be arms hanging down which will help make that more stable. Due to the excessive amount of 3D printing that's gone on in this episode, that's all I've got time for. Next time I'll be building some actuators to actually hopefully lift these up, which are going to fit just underneath, and also move them back and front hopefully. So don't forget to subscribe to my channel for more updates on this project and other projects, including my third BB-8 and my Hulkbuster suit. Also check out the social media links in the description to this video.